to this video. Today I'm gonna introduce the RSA algorithm and I'll give a simple example to show how the calculation details. The RSA algorithm is an asymmetric or with a public key cryptography. It can be used to encrypt the message or it can be used to build signature scheme. Well, today I'm gonna show you how we use the RSA to do the encryption. There's three steps. First, we need to build the key pairs, and we first choose two prime numbers, P and Q, and then we calculate the product of P and Q as n, and then calculate phi n, which is the Euler's torsion function. And here phi n is the number of integers that smaller than n but co-prime with n. And since n is the product of p times q, the phi n will be p minus 1 times q minus 1. And second, we choose a parameter e, which is co-prime with phi n. And then we calculate d as the inverse of e modulo phi n, or we can choose d and calculate e as the inverse of d modulo phi n. Both fine. And now we have the public key pu equals to ne, and the private key pr is d. And now we can use this key pair to do the encryption. Given a plain text m, we can calculate the ciphertext c as m to the power of d modulo n. And when the receiver receives the ciphertext, he or she can recover the plaintext by calculating c to the power of e modulo n. And this is how the RSA encryption works. And now let's see a simple example. So the first step, we choose P and Q, two prime numbers. So we set P as 3, Q is 11. These are prime numbers. And then we calculate N as P times Q, which is 33, and phi N, which is P minus 1 times Q minus 1. So that's 2 times 10, which is 20. And the second step, we choose a number which is co-prime with phi n. So we choose a number co-prime with 20, and here we choose 7. Then we calculate the inverse of 7 modulo 20. And well, to calculate the phi n here, we need to use the extended Euclidean algorithm. Let's see how this works. So we first write 20 as 2 times 7 plus 6, and then this 7 here, we can write it as 1 times this 6 here, and then plus 1. And so 6 equals to 6 times 1 plus 0. Actually, these three steps is to calculate the GCD of 20 and 7. And since we arrived at the remainder as 0, we know that the GCD of these two numbers is 1. And based on these equations, we can then do some substitution to get the inverse. Well, what we do is we use this equation here and we rewrite it as 1 equals to 7 minus 1 times 6. And then we substitute this 6 by this equation, the first one. And here we get this equal to 7 minus 1 times, well, 6 is actually 20 minus 2 times 7. So we can put it like this. And we simplify it and get 1 is actually equal to 3 times 7 minus 1 times 20. So now we have the inverse of 7 modulo 20 is this number here, is 3. So we get D is equal to 3. Now we have the public key as 33 and 7, and private key is 3. Now let's see the encryption process. So suppose the plain text M is equal to 2, then we calculate the corresponding ciphertext C. So we do the calculation here, which is 2 to the power of 7 modulo 33. Well, we first get the 2 to the power of 7 is 128, and then modulo 33 is 29. So this is the corresponding ciphertext. And when the sender send the ciphertext to the receiver receives C and then recover M as 23 to the power of D. Well, D is 3, so it is to the power of 3 modulo 33. And we can get that this result is 2. So the receiver recovers the message is 2. So this is the simple example. You can try the other little simple examples by yourself and see how this algorithm works. Well, for more details about the mathematics, you need to actually know about the prime numbers and how to find the how to do the modular operation and to find the inverse modular and how to use the extended Euclidean algorithm correctly, and also to do the calculation of exponential operations correctly. And that's how the RSA algorithm works. Thanks for watching. Bye.